Hello and welcome to the session number 2 on FIR filter design. In the last session, we have seen the comparison between analog and digital filter and digital filter input output relation in time domain and frequency domain and the applications of digital filters. Herewith, we will see what are the types of digital filters and their comparison. So typically there are two types of digital filters as in FIR and IIR. FIR stands for finite impulse response and IIR stands for infinite impulse response filter. Both type of the filters are basically LTI systems and they are characterized by their sample responses, that means the impulse response h of n. In case of FIR filters, impulse response is finite in length, that is, say from 0 to capital M, number of samples are present in FIR filter, hence the name finite impulse response. Whereas in case of IIR filters, the impulse response is 0 for n less than 0 and IIR system is basically a recursive system, a feedback system, wherein till the input is present, the system will produce the output, and in this sense, it is appearing to be having an infinite impulse response, and hence the name IIR filter. So herewith is the transfer function h of z for a filter in general, where AK and BK represents the filter coefficients. In this transfer function, if n is equal to 0, this system becomes a non-recursive system, a non-feedback system. Hence, h of z will take up a form of summation k equal to 0 to m bk into z raised to minus k, where bk will be the filter coefficients for FIR filters. And since denominator is absent, this expression where it contains only the bk and the numerator z polynomial, the FIR filters are termed as all zero filter. Whereas in case of IIR filters, it has got both bk and ak coefficients. So the system is a recursive system and system has both zeros from the numerator polynomial and poles from the denominator polynomial. Hence, this system is also called as pole zero system. FIR filters, they are designed directly in digital domain, whereas IIR filter design takes the already existing setup of analog filter design equations in order to obtain the transfer function h of s in analog domain, and then it is mapped, it is converted to the digital domain into h of z. Another set of differences between FIR and IIR are as follows. A difference equation for FIR is given as y of n is equal to 0 to n minus 1, where this represents the finite set of h of k coefficients, and the output depends only on present and past inputs. Whereas in case of IIR filters, where y of n depends both on present input, x of n minus k past inputs, y of n minus k past output samples, and thus it's a recursive system. So when we apply the Z transform for the difference equation forms of both FIR and IIR, it becomes h of z as a transfer function summation k equal to 0 to n minus 1 h of k z raised to minus k, and similarly the h of z, which comprise of ak and bk coefficients with respective summation limits, this becomes the transfer function for IIR filter. So another advantage on the part of FIR filter is FIR filters have linear phase characteristics, wherein IIR filter doesn't have a linear phase characteristics. A linear phase means phase response versus frequency, and linear means the phase response is linear, the phase varies linearly with respect to the frequency, is what is the characteristics of FIR filter. The reason is the filter coefficients are symmetric, and due to this linear characteristics, linear phase characteristics, the phase distortion offered by this system is minimal or zero, wherein the phase distortion can be expected when we use IIR filter. FIR filters are termed inherently stable, whereas IIR filter, in case of IIR filter, stability cannot be guaranteed. The reason FIR filter is termed stable because FIR filters are all zero filters. Therefore, all the poles of the system, they will be appearing at z equal to 0, that is at origin, in the pole 0 plot, which indicates poles for FIR filter will always reside inside the unit circle, and it will guarantee the stability for FIR filter. Whereas since IIR filter is a pole 0 filter, a careful design of this filter is needed, such as poles of this system will not go outside the unit circle, and that is why stability cannot always be guaranteed. Now, given the design problem, the filter design problem, FIR filter fulfills the requirement with more number of filter coefficients. This is the limitation on the part of FIR filter, wherein IIR filter will fulfill that requirement with lesser number of filter coefficients. So since FIR filter requires more coefficients, in turn hardware requirement will be more, memory requirement will be more in comparison to IIR filter. In case of IIR filter, some of the advantages are it has a better magnitude response and a sharper transition band as compared to FIR filters. FIR filter will fulfill this requirement of having better magnitude and a sharper transition width with higher number of filter coefficient values. An advantage on the part of FIR filter is it is less sensitive to finite word length errors, whereas IIR filters are more sensitive to finite word length errors.